Okay, so here I've sort of drawn the sort of route that Derry takes. Okay, so it's important to when you look at these graphs here that they are velocity time graphs. Okay, they're not illustrating like in this instance here. You might think, oh, he's going along the flat there, and then he's going up a hill. That's not the case with the velocity time graph because we're looking at how the velocity changes. This is what's actually going on, isn't it? For the journey. If I was to draw Derry here on his bike, he'd be going along a flat road there. So I'm looking at it sort of sideways on. He's going along a flat road, and then he gets to a hill and he climbs up that hill, and towards the top of the hill the gradient decreases, doesn't it? So it becomes less steep essentially. Okay, and then he comes to a stop. So that's looking at him actually on his bike sideways on. Okay, but here that's not doing that. It's looking at how his velocity changes with time, how his speed changes with time. Yeah. Now when I look at A here, you know, you might look at this and think, well, yeah, that's this kind of idea that I've got here. But remember, this is just looking at him sideways on. This is looking at his speed, what happens to his speed. So yeah, you know, I'd agree with you here. This bit, constant speed, because he's going along the flat. But watch what happens here. Watch what happens to his speed. His speed is actually increasing here. Now, would that actually happen? If you're going up a hill, would your speed increase? And that's not the case, isn't it? Your speed would decrease. So we can dismiss this straight away. This can't be our option because his speed isn't going to increase as he goes up the hill. Same with these here then, and these. Okay, so we're down then to these two here. Okay, so if we look at this one, constant speed. Okay, the same speed when he's going along the flat. Look then, we've got a sudden drop in speed, which would kind of make sense, doesn't it? Because as you're starting to climb up that hill, you have got a sudden drop in speed. Okay, so you can see the speed drops dramatically in a short space of time. Then he travels at a constant speed, okay, which is what you should expect, because if he's going up this hill here, okay, and he's working at the same rate throughout, and it's a constant sort of slope up, he should be staying at the same speed. But notice the speed is a lot less than when he was going on the flat, okay, which is what you'd expect. It'd be lower going up the hill. But then notice what happens. There's a peak again, isn't it? His speed actually increases. Now look at his journey. His speed should increase, shouldn't it? As the gradient of the hill, okay, decreases, as it becomes less steep, he should get faster, shouldn't he? So that makes sense. And then within a few seconds, then he comes to a stop. So that one there is the one I'd be thinking of. If you go to E, okay, with E, yeah, he's got the constant speed here, but notice it takes a long time for his speed to drop. His speed doesn't change the same, doesn't stay the same. It just drops over a long period of time, which wouldn't be the case. It would just sort of drop instantaneously as he starts to climb the hill, and it should stay the same then going up because he's going at the same rate throughout. So D is what we're going to go for. With part B,